In section 6 of chapter 3, we will talk about another form of the equation of a line and how we can use it to our advantage. The version of the equation of a line that we're going to work with in this lesson is called point-slope form. If a line has slope m and passes through a point x1, y1, then the equation can be written as y minus y1 equals m times x minus x1. Here's why this is helpful. If we know the slope of a line and we know one point on the line, then we can use that information to write the equation of the line. If you're wondering where this came from, I'll show you real quick. Recall that our equation for slope is m equals y2 minus y1 over x2 minus x1. Instead of x2 and y2 as the second point, we're going to swap those out for just the generic y and x as any point on the given line. So now we have m equals y minus y1 over x minus x1. Multiplying both sides of this equation by the denominator x minus x1 gives us x minus x1 times m equals y minus y1. This is the exact same thing as the point-slope form of the equation we have written here. The only difference is it's just flipped around. So now that we have the point-slope form, let's try using it in some examples. In example 1, we are asked to find the equation of a line that has the given slope and passes through the given point. In part B, we are given a slope, or m, of -3. We're also given the point 4, -6. That is, our x1 equals 4 and our y1 equals -6. Let's write down the point-slope form of the equation of a line. Now, instead of y minus y1, we want y minus -6. And instead of m, we can substitute -3. Finally, instead of x minus x1, we want x minus 4. Simplifying this, we will have the equation of our line. Y minus a -6 is y plus 6. Distributing our -3, we have -3 times x, or -3x, and -3 times -4, or positive 12. Subtracting 6 from both sides, we have y is equal to -3x plus 6. And now we have the equation of our line in slope-intercept form. This is the line with slope -3 that crosses through the point 4, -6. Let's go on to example 2. In example 2, we are told that the line associated with the linear function f of x has a slope of -4. That is, m equals -4. If f of -2 equals 13, find the function f of x. This time, our point is given to us in function notation. We're given that f of -2 equals 13. So when our x value is -2, we have an output value of 13. -2 is our x1, 13 is our y1. This corresponds to the ordered pair -2, 13, and it is a point on the graph of this linear function. Let's substitute these values into the point-slope form of the equation of a line. Now, instead of y minus y1, we want y minus 13. Instead of m, we will write -4. And instead of x minus x1, we want x minus -2. Parentheses here are very important. Let's use good order of operations to simplify. X minus -2 is inside our parentheses. We'll simplify that. Two negatives make a positive, so this is x plus 2. Now we can distribute the -4 to the x and the positive 2. -4 times x is -4x. -4 times 2 is -8. Finally, we'll add 13 to both sides to have y equals -4x plus 5. Now we have the equation of the line with the slope -4 passing through the point -2, 13. A really important step to not forget is we need to switch this back to function notation. Rewriting this in function notation, we will write f of x is equal to negative 4x plus 5. And now we have the function with a slope of negative 4, and f of negative 2 is positive 13. Let's look at one more example. In example 3, we have similar instructions where we need to find the equation of a line. But this time, instead of having the slope and 1 point, we are simply given 2 points. This is not a problem because we know how to find the slope from 2 points. M, the slope, is equal to y2 minus y1 over x2 minus x1, where x1, y1 is 1 point and x2, y2 is another point. Let's have this first point be x1, y1, and the second one x2, y2. Substituting those values in, we have m equals y2, or negative 3, minus y1, or 9, divided by x2, 4, minus x1, negative 2. In the numerator, we have negative 3 minus 9, or negative 12. In the denominator, we have 4 minus a negative 2. Two negatives make a positive, so this is 4 plus 2, or 6. Finally, negative 12 divided by positive 6 is negative 2. And now we have our slope. Now that we have our slope, we can use either of the two given points along with the point-slope form of the equation of a line to find our equation. We really can substitute either of these points into this equation, but for simplicity, I'll stick with what we've already labeled as x1 and y1. Substituting in our values, instead of y minus y1, we now have y minus 9. Instead of m, we write negative 2. And finally, instead of x minus x1, we have x minus negative 2. Using good order of operations, we'll simplify inside the parentheses first. We have x minus negative 2. Two negatives make a positive, so this is x plus 2. Distributing negative 2 to both terms inside the parentheses, we have negative 2x minus 4. Finally, we'll add 9 to both sides so that we have y equals negative 2x plus 5. And now we have the equation of the line through these 2 points. And that will conclude this video lecture.